All right, everybody, we're going to do a little review for Chapter 20 on solving triangles. It's actually going to go back to things that we did even before with SOHCAHTOA. So this is going to look at all different kinds of triangles. So we're going to go back and review SOHCAHTOA and Pythagorean theorem, law of sines, law of cosines, and finding area. So we're going to do some together, and then we will have you do some on your own and kind of check your work and see how you're doing with solving any kind of triangle. And so they're all sort of mixed up. So we want to see if we can separate out and see what kind of triangle we're dealing with. So the most important thing is to think about if you have a right triangle or not. So what I'm going to have you do first is take a moment, go ahead and pause the video, and go ahead and circle all the problem numbers of every triangle on the front side. We're just going to work on the front side of the sheet here that are right triangles. So anything that you see is a right triangle. So if you can take a moment, pause the video, and go ahead and circle all the problem numbers of the right triangles. All right, well, hopefully what you saw is all of the ones on the first two columns there, so 1 through 8, and then also number 10 on the front. All of those are right triangles. So our approach to all the ones that we circled is going to be a little bit different than the ones that don't have a right angle. So for all the ones we circled, we're going to be able to use SOHCAHTOA. So we're going to be able to use that to help us solve for either angles or sides. And we're also going to be able to use the Pythagorean theorem. So we're going to be able to do a squared plus b squared equals c squared to be able to solve for missing side lengths as well if we're given two sides. So SOHCAHTOA, so sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and Pythagorean theorem are kind of all in play. So I'd like to do one of each kind with you so you can see how each of those would work, and then we'll let you kind of go from there. So we'll do a couple of the right triangles. Let's just go ahead and start at number 1. I want you to think about what you're given and what you're trying to find, and then we'll see what we want to use for our trig ratio here. So it looks like we're given an angle, and then we're given a side length, and we're trying to find another side length. So our job is to figure out which trig ratio we're going to use to help us solve. So with respect to the angle that's 72 degrees down here, what side is the 6? So is that the opposite, the adjacent, or the hypotenuse? And then what side is the x? Is it the opposite, the adjacent, or the hypotenuse? If we can figure that out, we're going to be able to know what trig ratio to use. Probably the first thing that's easiest for people to figure out is start at the right angle and go across from the right angle, and that's always going to be your hypotenuse. So I know the x is the hypotenuse. Let's talk about the 6. So the 6 makes up part of that angle. That means it is adjacent to it. So this is the adjacent side. So we have the adjacent. We want the hypotenuse. Which trig ratio is that? So adjacent over hypotenuse, that is the so the cosine. So cosine of 72 degrees would be equal to the adjacent side, 6, over the hypotenuse, x. So being able to look at, hey, what do I have and what am I trying to find? Let's use the trig ratio that uses those. So now remember, if you have the x in the denominator and you're trying to solve, make sure you get that x out of the denominator first. So we're going to multiply both sides by x. So x times the cosine of 72 is equal to 6. And then we're going to divide by the cosine of 72. So being able to tell which trig ratio to use is critical. So we look at what we have and what we're trying to solve for. So we can go ahead and type that in. So go ahead and pause the video here. What mode should your calculator be in? Well, all of these we should be in degrees because we are calculating a degree mode thing. So 6 divided by the cosine of 72 degrees gives us 19.4. So this x, this other side, of the triangle here is 19.4. That's the hypotenuse. So we were able to find what that value is. Now the nice thing in all these, we're not doing a full solve the triangle where you find all the missing pieces. You're just looking for that one missing piece. So we'll do a little bit more here to practice a couple more of those trig ratios. What would I use and what am I trying to find? So let's take a peek at number 3. We'll just go right below here. So again, I'm going to have you take a look at what do you know about the triangle. So you're given an angle measurement. You're having a side x here and a side 12 there. So we know something about one of the sides and we're trying to find the other one. So again, it all goes back to relationship. For this 24-degree angle, what side of the triangle is the x? It's all the way across the triangle, so that's the opposite side. What side is the 12? Well, it's connected right to that 24. It's not the hypotenuse because the hypotenuse would be that longest side across in the right angle. So this has to be the adjacent. So what we're trying to find is the opposite. What we know is the adjacent, so which trig ratio is opposite over adjacent? tangent. All right, so we got tangent here. So tangent of 24 degrees would be equal to x over 12. Now, the nice thing, I wanted to do one of each type here. When your variable's in the numerator, a little bit easier for some people to solve there. How do we undo dividing by 12? Well, we just multiply both sides by 12. So x would be equal to 12 times the tangent of 24 degrees. And we can just do that calculation on our calculator and see what that value is. So 12 times the tangent of 24 degrees puts us at 5.3. So that side length for x would be 5.3, so that opposite side. So when we think about how we solve, it's always looking at what do we know and what are we trying to find. So in both of those, we had an angle and we had a side, and we were trying to find another side. All right, I want to take a look at it a little bit different scenario. Most of them are going to be like that, but not all of them. So let's take a look at one that isn't. So let's look at number 4. I want you to take a peek at number 4. I'm going to move this work here then. So take a look at number 4 and see what you know about the triangle. Looks like they're giving us a side, and they're giving us another side, and they want us to find the third side. So no one here doesn't mention any angles at all, which is totally fine. They're giving us 2 pieces of information about the triangle of the sides, and we're trying to find the third. So what's the relationship that relates the 3 sides in a right triangle? It's a famous Greek mathematician, Mr. Pythagoras. We need to use the Pythagorean theorem. A squared plus b squared equals c squared. Now, the tricky part is figuring out which side do I have, or which sides do I have, and what am I trying to find? Always find your hypotenuse first. That's the easiest thing. So look for your right angle, go across the triangle, especially when it's rotated like this. This one's the hypotenuse then. So that's like the side C in the Pythagorean theorem. It's the longest one. As far as the other two, the 2 legs, it doesn't really matter which one you call the A and the B. It's kind of like leg squared plus leg squared equals hypotenuse squared. A lot of people think of it that way. So one of the legs squared plus the other leg squared equals the hypotenuse squared. So whether you call this one A and then this one B or the other way around, it really doesn't matter. Just it's the 2 legs of the triangle. So we would have, let's set up the Pythagorean theorem then. We're going to have 6.3 squared plus x squared, I don't know the other leg, is going to be equal to 15.4 squared. So it's just a matter of solving that for x. So take a look and see what we know here. We can figure out what each of these are squared, and then we're going to be able to solve for x. So can you go ahead and on your calculator here and do 15.4 squared. So we'll do our arithmetic. So 15.4 squared. So that's 237.16. So 237.16. 6.3 squared. Let's do that arithmetic. So 6.3 squared. 39.69. And then that's plus x squared. Okay, where would you go from there? Well, how do we get the x by itself? Well, first thing is we're going to have to subtract that 39.69. And then after we do that, we're going to have to square root. So we're going to get x squared equals, so go ahead and subtract. That's 197.47. And then to undo squaring, we're going to square root. So x is going to be equal to whatever the square root of that is. So go ahead and type that into your calculator, and I'm coming up with 14.1-ish. So 14.1 would be the other side, and that would be in miles. Now think about this. Remember, this should be shorter than the 15.4 because it's not the hypotenuse of the triangle. So that's a reasonable answer that we're looking at. So for all of these right triangles, we're going back to this SOHCAHTOA again, and we're talking about being able to solve for the missing piece. So whether that's a side when you know 2 other sides, or whether that's a side when you know an angle on a side. So SOHCAHTOA Pythagorean theorem works awesome for those right triangles. So everything else on the front that you circled, we should be able to handle with one of those strategies, either a trig ratio or a trig ratio or the Pythagorean theorem. Let's talk about the other strategies that we have to use to solve non-right triangles. So I'm going to go ahead and start taking a look at those. So I'm going to make a new page here so we can kind of start fresh, and I'm going to get rid of the writing. So let's talk about the ones that aren't right triangles. So it looks like we have number 9, number 11, and then number 12. All right, so let's talk about what laws we would be using on these and see if we can do a little bit of solving. So let's take a look at number 9. They want us to find AB. So first of all, they're labeling this like we did back in geometry. So AB is this segment. Which angle is it across from? Well, it's across from angle C. So another way to say that is we're trying to find side C. So if you'd rather call it a C, so we can think of that, that would be great. Let's see about what we know in this triangle. We know 2 angles already. So it'd be really easy to calculate that third angle. We did that a lot. Do you remember how to calculate the third angle? What are the sum of the 3 angles in a triangle always add up to? Well, 180, and we can subtract off the other 2. So we can get that other angle, so angle A. So when we subtract and we get that angle, it'd be 16 degrees. Now here's the nice thing. I know angle A and I know side A. I know everything about A, so I have an angle and a side across. Do you remember what law we have to use? Either sines or cosines when we know a side and an angle that's across. Hopefully you remember that's going to be law of sines. So we can set up our proportion. So we'd say 9 is to the sine of 16 degrees, angle A, as, now what do they want us to find? Little c. So little c is to the sine of 63. So this is going to be a cross multiply divide. So you're going to multiply across the equal sign. So little c is going to be 9 times the sine of 63 divided by the sine of 16. Remember to finish off those parentheses. We've done a lot of these, but make sure that you're being cautious with how you're writing those out so you can make sure that you're okay. So go ahead and type that in, see what you come up with. And I'm coming up with 29.1 if we round to the nearest tenth. So little c would be 29.1. So we could do lots of different things, but it's always looking at what do I know about the triangle. For number 11, you actually know all of the sides of the triangle, and you're trying to find angle C. So in this case, it's going to be another situation where, hey, I know everything about angle A and the side across from it, little a, so I'm going to be able to use law of sines. This is one that you're going to have to use inverses for, though. So I'm going to help you set up the proportion and then see if you can go ahead and do the solving. So when we set up our proportion, I know 26 is to the sine of 88 degrees, so law of sines, as little c, 21, is to the sine of angle C. So I'm going to see if you guys can solve this one. So I kind of helped you get it set up, but we're going to cross multiply and divide, but then remember that's going to be sine of C. So remember how we undo something? We do its inverse. You're going to be doing that inverse sign on both sides. That's what undoes over here and gets us that angle measurement. So I'm going to have you try to see if you can finish that one off on your own. All right, let's take a look at number 12. It's giving you a little hint there, actually kind of telling you, but let's see, why would we need to use law of cosines? Why can't you use law of sines on number 12? Well, take a look. What do you know about the triangle? You know all 3 sides. So if we're trying to find something using law of sines, I'd be really out of luck because I don't have an angle measurement to set up that proportion. So I really do need to use that law of cosines to find that angle. So they're asking us to find angle A using law of cosines. That means we have 2 different choices. Remember, we had the kind of like that standard format where we were solving for a side, and then the alternate form that we were solving for an angle. So if you can look up in your notes packet, find that alternate form. That's the one that you're going to want here. You're going to want the one that's solved for cosine of A. So that's going to be your b squared plus c squared minus a squared over 2bc. So it's a little bit easier to be able to deal with those values because we're going to be able to solve it faster if we have that alternate form. So let's go ahead and see if we can plug those in and how we solve this. And we can talk about that inverse idea that you're going to need for number 11. So let's go ahead and make sure we know which one's which. The b is 17, little a is 10, and little c is 11. So the cosine of a would be equal to 17 squared plus 11 squared minus 10 squared over 2 times 17 times 11. Now, when we did law of cosines, we talked about lots of different ways that people do this. It's kind of a personal preference. Some people do the whole numerator, so they type everything in on that whole numerator first. So 11 squared minus 10 squared, and they get that answer. And then they do the denominator, so 2 times 17 times 11. and then they just divide those two numbers. So 310 divided by 374, that would be what cosine is. If you'd rather see it as a fraction, if that's more user-friendly for you, we got 155 over 187. So the cosine of angle A, 155 over 187. Now remember, that's not our final answer, right? That's just us being able to see what the ratio is. I want what A is, just angle A. So I need to undo this cosine. So this is where we do the opposite. We take the inverse on each side, and this is totally on your calculator. So we'd have cosine, inverse cosine undo each other, and then we just need to evaluate that on our calculator. Again, make sure you're in degrees. So we're going to do inverse cosine of our answer, and we're going to get 34. And I guess 0.0, so 34.0 degrees. So we can solve for that other angle. So law of cosines works great if we have three sides, so side, side, side. Also would work awesome in side, angle, side. That was the other scenario we did for law of cosine. So we had both of those options. All right, the last thing we're going to talk about is area. So I'm going to have you go ahead and flip it over to the back. We had two different area formulas that we talked about, and it depends on what you know about the triangle. So the two different area formulas were if we know side, angle, side, that's where you use the formula, the area is 1/2 AB times the sine of C, or whatever letters you have. If you have side, 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 that's where we use that Heron's formula, which was using that semi-perimeter. If you remember that, you can look back in your notes. That was the second day on section 20-3. This is the S, S minus A, S minus B, S minus C, where S is the semi-perimeter. Remember, semi means half of something, like a semicircle. So where we add up the three sides, that's the perimeter of the triangle, and then divide by 2. So those are our two options. It's really going to go back to, hey, do I know side, angle, side, or do I know side, side, side? And if I don't know either of those, what would it be most like? So let's take a look at on the back side. Can you go through and look at the 4 examples? Which one of them are side, side, side? Are any of those where you know the 3 sides of the triangle? So go ahead and pause the video and see if you can circle the problem numbers of the ones that are side, side, side. Well, hopefully what you were looking at were 14 and 16. Those are the ones that are side, side, side. So I'm going to kind of get you started for one of them, and then you can go ahead and finish off the other one. I'll do 16 because it's on the bottom here. It'll be a little bit easier. So first order of business, find your semi-perimeter. So we're going to add up the 3 sides. Doesn't matter which one you call what. And then we are going to go ahead and calculate that value. So it looks like that would be 19.5. So we add up the 3 sides. Then to calculate the area, we're just going to evaluate that big square root. So we're going to be doing S, so 19.5, and then 19.5 minus each of the side lengths. So it really doesn't matter. There's a decimal point there. Which side you call the A, the B, and the C, it's just the subtraction. So 19.5 minus each of those sides. Now again, for me, sometimes it's easier instead of typing in all of those parentheses. Sometimes what I'll do is I'll write what those things are subtracted. So like 19.5 minus 12 is 7.5. 19.5 take away 13 is 6.5. And then 19.5 minus 14 is 5.5. If that's like an easier thing for you to type in, might make your work a little bit easier. So let's take a peek here. So if we're going to type that in, we can do the product first if you want. So 19.5 times 7.5 times 6.5 times 5.5. So I get that big 5,000 number, but remember, that's what just the under part is. And I need to take the square root of my answer, and then I would get 72.3. So the area, 72.3. And that would be in square units, whatever your units are. Remember, this is an area, so 72.3, that's a goofy 72. That's bugging me. So 72.3, whatever your units are squared. So Heron's formula works awesome if you have side angles or 3 sides. So side, side, side. Now take a look at the other ones. Do we have side, angle, side? So let's take a peek and see what we know about each triangle. Look at the side lengths that you have. So I have this side right here, and I have that side right there. Do you know the angle that's in between them? Absolutely. So this is side, angle, side. How about down here? I have this side, I have an angle, I have that side. So this is side, angle, side as well. well. If you didn't have side angle side, you might have to find another piece. I know we had to do that in the notes. So let's practice one of these, and you can go back and do the other one as well. So you identifying what you know about the triangle will help you decide what you're actually going to, which formula is actually going to make the most sense. So for side angle side, our area is 1/2. I'm just going to use the AB sine of C. Now remember, the letters don't matter so much. Just think of it side, side, and then sine of the included angle. So if you wanted to call, this would be my angle C, and the A and the B, that's great. Try not to get hung up on the labels. Just remember, you're always going to do 1/2, and you're going to multiply the side times the other side times the sine of the angle that's included in between that side angle side. And we just multiply. So we're going to multiply those together. So we've got 0.5 times 29 times, can't remember the other number, 8, and times the sine of the angle included, the 100. All right, which gives us 114.2 if we round to tenths. So 114.2. What units would it be in? Well, this is area again. These were in centimeters. So this is a centimeter times a centimeter would give us centimeters squared. So we're looking for the area. So the big part about area is just knowing, hey, what do I have? What do I know? If it's 3 sides, Huron's formula works awesome. If it's side angle side, we're going to use that 1/2 AB sine of C, and it works great. So the whole idea here in these chapters were to try to help us solve for different types of triangles. So whether it's a right triangle where you're using SOHCAHTOA and Pythagorean theorem, or if it's a non-right triangle and you're using law of sines or law of cosines or finding area, that we have tools and strategies to find sides and angles.